We've been looking for life on Mars in all the wrong places. For decades, we've stared at the dusty, frozen surface, hunting for traces of ancient riverbeds and patches of ice. But what if the real treasure isn't sitting on the surface at all? What if the smoking gun for Martian life is actually hidden thousands of meters beneath our feet, trapped in a dark, liquid world we can barely touch? Welcome to SciNova. Today we are diving deep, literally, into one of the most groundbreaking discoveries in planetary science. We aren't talking about the frozen plains or the polar caps that we've known about for years. We are talking about seismic anomalies that suggest Mars might be hiding massive liquid water reservoirs deep within its crust. This isn't just speculation. It's backed by data that is forcing us to rethink the entire history of the red planet. To understand why this is such a shock, we first have to address the obvious. The surface of Mars is a death trap for liquid water. It is brutally, consistently cold. The atmospheric pressure is so low that if you tried to pour a glass of water on the surface, it would either freeze instantly or boil away into vapor. This is why we've spent so much time studying the South Polar layered deposits, where water ice covers at least 80.5% of the area. It's a frozen desert, but a desert is not an ocean. So, if the surface is a frozen wasteland, where is the water? The answer lies in the seismic data. Scientists have been using seismic inversion, essentially using Marsquakes to listen to the planet's interior, and they found something startling. At a depth of 5.4 to 8 kilometers, there is a significant low-velocity anomaly. In plain English, something is slowing down the seismic waves, and that something behaves exactly like liquid water at the base of the upper crust. This low-velocity anomaly is a massive clue. When seismic waves travel through solid rock, they move fast. When they hit liquid, they slow down significantly. Finding this specific signature at that specific depth suggests that we aren't just looking at damp soil or trapped ice. We are looking at a substantial volume of liquid. It's a layer of moisture that shouldn't exist, according to our old models of a dead planet. But let's go even deeper. The data suggests that the liquid water might not just be a thin layer. There are indications that water may reside within fractured igneous rocks, or even within the tiny pores of the rocks themselves, at depths of approximately 10 to 20 kilometers. Imagine a massive, planet-wide sponge made of volcanic rock, saturated with liquid water deep beneath the surface. It's an immense, hidden plumbing system that we are only just beginning to map. Why does this matter? Because where there is liquid water, there is the potential for life. On Earth, life thrives in the deep crust, in hydrothermal vents, and in underground aquifers far away from the sun. If Mars has these deep, protected reservoirs, it provides a stable environment, shielded from the sun's lethal radiation and the planet's extreme surface temperatures. We may have been looking for little green men on the surface, when we should have been looking for microbes in the deep dark. Now, I know what you're thinking. If there's water, why can't we just go get it? Well, that's the catch. This water is incredibly hard to reach. We are talking about depths of up to 20 kilometers. To put that in perspective, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, only reached about 12 kilometers. And that took 20 years of intense effort. On Mars, with our current technology, tapping into these reservoirs is a monumental engineering challenge that is decades, if not centuries, away. This discovery changes the habitability timeline of Mars. It suggests that even as Mars lost its thick atmosphere and its surface became a frozen wasteland, its interior might have remained a sanctuary. The planet's internal heat could have kept these deep layers warm enough to maintain liquid water long after the surface died. This means Mars might not be a dead planet, but a dormant one, with a biological heartbeat pulsing deep underground. Let's look at the scale of this. We've previously focused on the south polar layered deposits, knowing that ice covers a huge portion of that region. But ice is static. It's just sitting there. Liquid water, however, is dynamic. It can flow, it can circulate, and it can carry chemical nutrients and energy. A liquid reservoir isn't just a puddle, it's a circulatory system. This could mean that Mars has a much more complex geochemical cycle than we ever dared to imagine. Of course, we have to remain cautious. While the seismic data is compelling, it is still an indirect measurement. We are essentially listening to the planet and making an educated guess about what the sounds mean. We haven't actually seen this water with a camera or touched it with a rover. There is a possibility that these anomalies could be caused by other things like partially molten rock or different mineral compositions, but the probability of it being water is currently our best scientific lead. The next step for NASA and other space agencies is to refine our seismic models. We need more sensors on the surface to get a higher resolution ultrasound of the Martian interior. If we can confirm these reservoirs, it will completely shift the target for future Mars missions. Instead of just looking for fossils in the dust, we might be designing missions to drill deep into the crust to find living organisms. It is a humbling thought. We've spent so much time looking up at the stars, wondering if we are alone, while the answer might be right beneath the surface of the very planet we are trying to visit. The red planet is far more mysterious and far more alive than we ever gave it credit for. The oceans of Mars aren't gone. They've just gone into hiding. If you found this deep dive into the Martian mysteries fascinating, make sure to hit that like button and subscribe to SciNova. We are constantly tracking the latest breakthroughs in space and science to bring you the truth about our universe. Thanks for watching, and we'll see you in the next discovery.